Warm up for lesson 6-5. Pause, and here's the answer. 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 Lesson 6-5, Operations with Radical Expressions. Let's continue to simplify radical expressions, add, subtract, multiply, and divide radical expressions. This is called the product property of radicals, and it says that a root of a product is equal to the product of the two roots. The product of the two roots is equal to the root of the answer of the product. And we can do this with a third root as well as a square root. Let's go ahead and do an example. So I'm going to write this square root like this. Now I know 32 is 16 times 2. 16 is a perfect square. This is x to the second, x to the second, x to the second, x to the second. That's 8 x's. Now the square root of 16 is 4, and square root of 2. Now square root of x squared is x, 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 x. Let's clean it up, and we'll say 4x to the fourth power, and we like to write the roots at the very end. Let's do a fourth root. Now 16 is really 2 to the fourth power, and a to the 24th is a to the fourth, a to the fourth, and this will be 6 times to make the 24. And 1, 2, 3, 4, 5, and I need one more, 6. And then b to the fourth, b to the fourth, b to the fourth, that is 12, and then one more b to make the 13. So when I take the fourth root of 2 to the 4, it'll be a 2, and there will be an a for each one of these. 1, 2, 3, 4, 5, 6. So this will be a to the 6. Instead of me writing it all out, there will be 3 b's, b to the third, and there will be a b left in this fourth root. And there's my answer. Let me show you again. So this is going to be the square root of 4 times 3 times c to the second, c to the second, c to the second. So that's 6 of them. D to the second times d. So the square root of 4 is 2. We've got to leave root 3. And then this will be 1, 2, 3, c to the third times d. And then we have a root d. Let's pull all these together and get the roots together. And since this is a root and this is a root, the product of the roots is the root of the product, which is 3d. Now let's do this third root. 27 is 3 to the third, y to the third, y to the third, y to the third, and then that'll create one more y to the third. That's going to create y to the 12th, c to the third, c to the third, and z. That'll create the 7th. Okay, now I'm going to take the root of 3 to the third, which is 3, 1, 2, 3, 4, y to the fourth, z to the second, because this is going to be a z and a z, and then we'll have the third root of z right here. Okay, you try it, and here's the answer. Now I put the absolute value here because I've got to ensure that this answer is positive, and since these are odd powers could lead to a negative number, and we want to ensure that that's going to be positive. Let's talk about the quotient property of radicals. So the root of a quotient is a quotient of the roots. Here's the quotient of the roots, and this is the root of the answer here. Let's also talk about rationalizing the denominator. When you have a root in the denominator, you don't want to leave it that way. You want to multiply the numerator and denominator by that root. Now when we talk about other root powers, we're going to do that in just one moment, and I'll show you how to work those kind of problems. So this is a square root, and so what I'm going to do is I'm going to write it separately. So this is x to the second, x to the second, x to the second. That makes the 6. And then this is going to be root y to the second, y to the second, y to the second, and then there's a y. You can see that there is a y that will not be able to come out of the root unless I multiply it by a root y, because then this will create a y squared. Whatever I do to the denominator, I must do to the numerator. This is called rationalizing. So now in the numerator, I can get all of these x's out of the root. So this is x to the third power, but this root y is still there. Now I can take out 1, 2, 3, and now with this I can take out 4, y to the fourth, and this is my answer. Okay, so this is the fourth root of 2 times 3, and then this is the fourth root of 5 times x. Now we can't take that out of the fourth root unless there are 4 5s. So I'm going to multiply by the fourth root of 5 times 5 times 5. So that's going to create 1, 2, 3, 4. And then I also want 4 x's. So I'm going to multiply by another 3 of them. And I want to multiply by the fourth root of the same thing that I put in red there. So now this is going to be the fourth root, and this is going to be 125, and then this will be a 6. 0 carry a 3. So that's 750 x to the third power all over. And now that I have 4 5s, the root of 5 to the fourth power is 5, and then I have an x. And that's my answer. Let's do it again. This time I'm going to do square root of a squared, a squared, a squared, a squared, and then an a. And it's the denominator I'm most concerned about, not the numerator. B squared times b. And you can see I have a b that doesn't have another factor, so that'll be perfect. So I'm going to multiply by root b so that I can create this b squared. And I'm going to do whatever do to the denominator, I must do the numerator. I'm going to be able to take out all of these a's, so a to the fourth, but there will be an a and a b left at the square root. Now every one of these b's is now going to be square, so this is going to be b to the third. Now this is the fifth root of 3 all over the fifth root of 2 times 2 times y. Alright, now what I'd like to do is times by a fifth root, but I want to make sure there's 5 of these 2's. So I'm going to put 3 more. I only have 1 y, so I've got to multiply by 4 more in order for that to be y to the fifth. And that's what I want to do to my numerator here too. So that'll be an 8, and that'll be a y to the fourth power. So when I simplify it, it'll be a fifth root. 3 times 8 is 24, y to the fourth. And I'll be able to take out a 2 out of the fifth root, and I'll be able to take a y out of that fifth root too. And there's my answer. Pause. And here's the answer. Pause. And here's the answer. Now let's talk about simplifying radical expressions. One of the things is we don't want radicals to appear in the denominator. We don't want a radicand to have any fractions, and we want to take all factors out of the root. So let me give you some examples here. Okay, I have some numbers outside the root symbol, so I'm going to just call that 15. And then I have a third root, and I'm just going to put it all together. And this is going to be a -1 times, and then 12 is 2 times 2 times 3, and I'm going to do 18, and 18 is 9, 3 times 3 times 2. I've got an a here, and I've got 2 more a's here. I've got b to the fourth, and I've got 2 more b's here. Now what I'm looking for is looking for cubes, and I can see I have a cube here, 3 to the cube, and 2 to the cube, a to the cube, b to the third power, and b to the third power. So here's my answer. I'm going to have, this is going to be cube root of -1, which I know is negative 15, times, now I'm going to get a 2 out, a 3 out, an a, and I'm going to get b squared here. Let's multiply this out. This is 15 times 6, and that's going to be -90 ab squared. Okay, let's go ahead and continue practice. This is going to be a 24, and I'm going to put everything under my root. So this is going to be 8 times 2 is 16. This is going to be c to the, there's 4 c's, so this will be c squared times c squared, because there's going to be 4 c's. And there's going to be 8 d's, d squared, d squared, d squared, d squared. So this is going to be 24. I know the square root of 16 is 4, and this is going to be c squared d to the 4th. And when I multiply this, this is going to be 96 c squared d to the 4th. Okay, multiplying again, this is going to be 6, and then I'm have a 4th root here. And let's see, this is 8 and 2, which is 16, and 16 is 2 to the 4th power. And then this is x to the 8th power, and x to the 8th power is x to the 4 times x to the 4. Y squared and y squared will be y to the 4th. So now we can take the 4th root of all of these. That's 6 times 2 times x squared times y, or 12x squared y. Your turn. And here's the answer. All right, let's talk about adding and subtracting. And in order to add or subtract, you got to add like terms. This is an example of like terms. Root 3b, 4 root 3b. As long as the expression under the radical is the same, they're like terms. But these two are not like because one's a square root, one's a cube root. These are not like because what's under the square root are different, 2b and 3b. So let's go ahead and do this problem. Root 98 is 49 times 2. And root 32 is 16 times 2. So this is going to be 7 root 2 minus 2, and root 16 is a 4, root 2. So this is 7 root 2 minus 8 root 2. Now these are like terms, and so the answer will be negative root 2. Over here, this is 4 root 4 times 2, and root 50 is 25 times 2. So this is root 4 is 2, so this is 8 root 2 plus, we know our root 25 is 5, so this is 15 root 2. These are like terms, so this is 23 root 2. This is 5 root 4 times 3 plus 2 times 9 times 3 minus root, and this is 64 times 2. So root 4 is 2, this is 10 root 3 plus, this is root 3, which is root 9, which is 3, 6 root 3, and then root 64 is 8 root 2. Now these are the like terms that you can put together, and you're going to not be able to do any combining with a root 2 because that's not a like term. Pause, and here's the answer. All right, let's talk about multiplying radicals. Multiplying radicals is similar to what we did with polynomials. You're going to have to distribute, and if you want to use the word FOIL to help you remember all the distribution, then that's probably a good idea. So you're going to have to make sure you multiply all those, simplify, and add like terms. Now watch me as I do the problem. So I'm going to go ahead and multiply these two. And that answer is going to be 12 root 15. And then 6 times 4 is 24. And root 3 times root 2 is root 6. Now I'm going to be multiplying here and here, minus 10 root 5. And then right here will be negative 20 root 2. None of these are like terms, so you just leave the answer the way it is. Multiplying these two, that's 49 times root 4. I'll simplify later. And then multiply this and this. That's plus 21 root 6. Multiply these two, minus 21 root 6. And multiply these two, and that's minus 9 times 3. Now, I don't know if you noticed it, but this is called a conjugate because they're the same, the first and the end. One's positive and one's negative. Now, this simplifies to 49 times 2, which is 98. And these two will go to 0. And then this is minus 27. And 98 take away 27 is 71. So 71 is the answer to this multiplication problem. Pause. And here's the answer. Okay, last example is, most of the examples we've been working have a simple square root in the denominator. And when we do that, we just multiply numerator and denominator by that root. And when that happens, then we don't get a root in the denominator anymore. This problem is a little different in that it is a difference. And when you have a difference, you have to multiply by the conjugate. So we're going to take root 5 plus 1, root 5 plus 1, and we're going to multiply all this, and you're going to notice your inner and your outer are going to go to 0. And then you're going to end up with a expression that has no root. But then you're going to have to remember to distribute here. That's what we're doing right here. And you can see they all have a common factor, which we can continue to reduce.